Welcome back, everybody. It's Mr. Rootsart, and we're going to look at the properties of ionic compounds today. Properties of ionic compounds, something you have to memorize. All ionic compounds have these properties, so pay attention, memorize these, and they all share these. So the first thing is that they have a high melting point, so that's why most of them are solid at room temperature. Okay, so solid at room temp. And moving on, soluble in water. So what does that mean? That means they're going to dissolve in water. Now, how does this work? Well, it all has to do with this bad boy right here. This is our water molecule, and that's because water is polarized. Okay, and what that means is that one side of it is going to be negatively charged, and the other side is going to be positively charged. So what does that have to do with ionic compounds? Well, when they get into water, let's say we have sodium chloride. We know that sodium ion is positively charged and chloride is negatively charged. So what that means is water being polarized, one side of it is positively charged, the other side is negatively charged. So it's actually going to pull this compound apart. The bonds here between in molecular compounds are very strong and very difficult to break apart. Easy to break these ones apart. So our negative ion is going to be attracted to the positive side of water, and our positive ion is going to be attracted to the negative side of the water, which means that it's going to pull apart that way. So basically, that's how the dissolving takes place. All right, moving on. They are all conductive solutions. So that means that they form an electrolyte. And how does that happen? Well, again, if we use salt again, so sodium chloride, because we have charged particles in there, these charged particles allow for one side to be positively charged, which is going to move electrons, and the other side to be negatively charged, which is also going to cause the electrons to be repelled from here, attracted to here, which will make them move through our basically through our little circuit. Now, how is that going to work? They're not going to work on their own. That would be a great little process if that could happen. This here is actually a battery. Okay, and that just allows the water. It shows that it can be conductive across here. If we had sugar in here, sugar is a molecular compound. This would not happen at all. So now we're going to take a look at what we're talking about is the retention of a crystal shape. So what does that mean? Let's say we have a large piece of salt. I keep on picking on salt. So if we have salt, that's going to form a large crystal. Now if I hammer that salt, it just breaks into smaller crystals. Even though sometimes if I continue to pound it and it looks like I'm pounding it into a dust, that is still going to retain a crystal shape. They're not going to look all the same, but it's going to retain a crystal shape. So that's why we have I have a number of different crystals here. So it's going to have a retention of crystal shape if I break it into smaller pieces. So those are the properties of ionic compounds. You just have to memorize those, get to know them, understand what they are. Remember, all ionic compounds share the same properties. I hope this was informative, and we will see you in class.